Okay, this is 10.3. Go ahead and do the warm-up. And then we're going to start solving by graphing today. So we solved systems by graphing earlier, and now we're going to solve quadratics. So what we need to understand is that when you are asked to solve a quadratic equation, you're being asked to find where it crosses the x-axis. Okay, that's what that means. So if you're asked to solve a quadratic, you need to find where that parabola crosses the x-axis. We've actually already done this because we can do it by factoring. But today we're going to do it with graphing. Okay, but that's what we found when we factored and solved. There are lots of names for these. They're solutions. They can be roots because they root your parabola to that axis. They ground it, okay? They are zeros because whenever you're on the x-axis, your y is 0, okay? Solutions, roots, zeros, x-intercepts are all the same thing. So we're going to solve them by graphing today. We did it by factoring. So if we had something that was x plus 2 and x minus 3 when we factored it equals 0, then that would cross the x-axis at -2 and a positive 3. Those were my x-intercepts. Those are my roots. Those are my zeros. We can find it by graphing. We can put it in Desmos and see that that's where they cross, okay? Now, we have to understand that not all parabolas are going to cross the x-axis, okay? So if you think about your coordinate plane, you can have just a normal old parabola that crosses twice. That's pretty typical. You can have one that doesn't cross at all because the maximum or the minimum are above or below the x-axis. So since that's my highest point and it's below the x-axis, that's never going to cross. I'm not going to have any roots. Then the last option is what we call a double root. If your vertex is on the x-axis, then that's the only point that crosses. So you can have no solutions. You can have 2 solutions, or you can have 1. Those are our options, okay? No roots, 1 root, 2 roots. If it is 1, it is called a double root, okay? A double root is always where a graph changes direction. So it kind of bounces off of that x-axis and comes back up, making that a double root. If you were to factor an equation that had a double root, you would end up with the same answer twice. They come from perfect square trinomials. So it would be like x minus 5 and x minus 5, and you would get that x is 5 twice. Can't cross at 5 twice. It's just a double root. Your vertex is on the x-axis. No roots, it cannot cross at all. Okay, so this one has a minimum that's higher than the x-axis, so it's never going to cross. Rational roots can cross at not pretty numbers, basically. If it's not going to cross at 3 and -2 all the time, they're going to cross at decimals, but that's okay, because we're just going to use Desmos to help us figure that out. All right, f of x, don't get thrown off by function notation. Remember, f of x is just another way of saying y, and so in Desmos, you can just put y equals, okay? So, or you can put f of x, but y equals x squared plus 4x plus 4. So here is our graph. We are looking for the answer, so we're looking for where it crosses the x-axis. If you tap your graph, tap it one more time, it gives you that point. So the solution, my answer, my roots, I have 1 root, okay, because it only crosses once. That makes it a double root because my vertex is on the x-axis, and it is where x is -2. That's it. Okay, I have 1 root, it's a double root, x is -2. On your homework, I want you to include screenshots too. I'm just not going to do that right now. Okay, so now we have x squared minus x and minus 4. and you zoom out until you can find exactly where it crosses the x-axis. So this has 2 roots because it crosses the crosses the x-axis twice, and they are at x equals negative 1.562 and at x equals 2.562. So they are rational roots. They're not pretty numbers, but it does cross twice. So those are my answers. Okay, now let's do x squared plus 6x plus 7. It crosses the axis twice, so this has 2 roots. At x equals negative 4.414. And again at x equals negative 1.586. It's just that easy. I just put in decimals and see how many times and where it crosses the x-axis. I don't know why I didn't do any negatives. Why are these the exact same thing? Okay. Let's do a negative x squared plus 4x plus 3 and see what happens. So y equals negative x squared plus 4x plus 3. So it opens down this time, but it still crosses twice. So this has 2 roots, and then that's where they are. And that's it. Okay, so in your homework, make sure you include the screenshot. Just tell me how many roots and where they are. And that's it. 10-3.